Hey guys, Jake here coming at you with another math lesson today. Today we're going to be talking about compound interest and how you can calculate basically the amount that's in an account based on different compound interest. So before we jump in, I'm going to have a practice problem here in a minute, but before we jump into that, I just want to talk about compound interest in general a little bit. So first of all, here is basically a formula and kind of an explanation of what the different components of this formula actually mean. Let's say we have a situation where we know we have compound interest. So compound interest is basically just a situation where you put some amount of money into an account, and that interest, you're going to earn interest on the money that's sitting in that account. The interest is typically going to be compounded a certain amount of times per year. So in that sort of a situation, this is the applicable formula. So this is the formula you'd use if you have some sort of thing like this. After T years, the balance A in an account with principal P and an annual interest rate R in decimal form is given by this equation. A equals P times 1 plus R over N in parentheses raised to the N times T for N compoundings per year. So there's a lot of things to talk about here. Let's break this down. There's several different variables, several different pieces here. This is another example. I know lately I've been trying to talk about kind of textbook explanations of different concepts because I think it's important to understand how textbooks phrase things. So let's talk about this. So you can see right off the bat, it starts out by saying after T years. So right there, that tells you T represents a number of years, okay? Then we have the balance, A. So this tells you our balance in our account is given by A, with principal P. So P is the principal. Principal just means the amount of money that you first put into the account. So that's an important distinction here. Basically, this equation is important to use, or it's important to notice that you use it when you have just an initial investment. Let's say I put $1,000 into an account today. I know how long I'm going to leave it there. I know maybe what the interest rate's going to be. I can use those pieces to calculate what my account balance is going to be at the end of a certain amount of time, okay? Then we also know we have an annual interest rate. Notice it says annual. You want to be careful of that, and I'll circle back to that in a bit. But an annual interest rate R in decimal form, so typically an interest rate a lot of times will be given in a percentage, 5% per year or something like that. You want to convert a percentage into decimal form. And we have N compoundings per year. So N is the number of times it's compounded per year. So usually in these compound interest problems, they'll tell you your interest is going to be compounded annually or biannually or quarterly or monthly or weekly or daily. So it's going to give a certain amount of times that it's compounded per year. So it'll usually say something like that, compounded daily, compounded weekly. You then have to convert that to a number N, which is the number of times it's compounded per year. And again, I'll go into an example and explain what that means. But that's an important thing to kind of consider. So a common kind of, I don't really want to call it a trick question. It's really just to make sure you're paying attention to the details. Because in real life, a problem like this where you're trying to figure out what you want to do with an investment or where you want to leave your money, you're saving up your hard-earned money, you want to try and figure out the best place to put it. This is a real world example of how pre-calculus or college algebra can actually come in handy in real life. You want to evaluate, the difference between two different savings accounts. Do I want to put my savings in this account? Do I want to put my savings in this account? This is a way that you can actually calculate how much each account is going to be worth in a certain amount of time and pick which account makes more sense for you. So again, I'm not trying to say anything in this video is going to be some sort of like financial advice or anything like that. But, these are actual like helpful tools for real world examples with what to do with your savings. So here's the formula. Let's talk about how to actually use that. Before we jump into that, I do want to point out, go check out jakesmathlessons.com/precalculus-study-guide, this URL up in the upper right-hand corner of your screen, or scan this QR code. I recently came out with a pre-calculus study guide. It'll save you a ton of time as you do homework, study for tests, anything in a college algebra pre-calculus course. I promise that's going to be a huge lifesaver for you. So go check that out. It's available for instant download. You can literally have it in seconds if you go over to that website. There's more info there too. It doesn't just jump you straight into grabbing that. So, but go check that out. But let's jump into an example and I'll show you how to actually apply this. So here's a problem that you might run into. Determine the principal P that must be invested at rate R, compounded monthly, so that $500,000 will be available for retirement in T years. So again, this is a very practical example of compound interest and how this is used. Compound interest is typically the way interest is actually accrued in real life, in real investments. You put money in a savings account, it's going to be compounded a certain amount of times per year. If you just leave that money in the account, then that interest from this year is going to be compounded next year, or the interest this month is going to be compounded on next month. If you put money into the stock market or whatever, invest in some bonds, whatever the case is, typically those kind of returns and yields that you're going to be calculating is sort of a compound interest situation. Really, savings accounts are really the main time when something as straightforward as you get a certain amount of compounded interest, that's really the main place where that comes up. Something like an investment in a stock or something like that, it has ups and downs, right? A savings account is just going to compound interest and gain a little bit each month, each quarter, each year, whatever the case is. In this case, we know that our interest is compounded monthly. So every month, we're going to get a certain amount of interest, depending on how much money is in our account at the end of that month. So keep in mind here, we want to kind of break down what the problem is telling us, what the problem is asking us to find. That's a good strategy with any math problem, but especially in these compound interest problems where, look back at this formula, we've got A, P, R, N, and T. We have 5 different variables that we have to either plug in for or solve for. So you really want to kind of figure out the different pieces that you're trying to find and the different pieces that you are given. So it tells us we want to determine the principal P. So right there, determine the principal P. We're trying to find P. We need to solve for P. So right there, P in this equation is what we're trying to solve for. So theoretically, we probably have the other 4 letters, other 4 variables, somewhere else in our problem. Or if not, then our answer may depend on one of those other letters. We want to find the principal P that must be invested at rate R, compounded monthly, so that $500,000 will be available for retirement in T years. Then the problem tells us that R is 12% and T is 40. So right there, we know that R has been given 12% in 40 years. We know it's compounded monthly, so that gives us some information about N. It's N compoundings per year. And we're putting $500,000 into the account. Or I'm sorry, that's not right. We want $500,000 in T years. So $500,000 is what we need the account to be worth at the end of 40 years. So let's kind of break down what these 2 things actually relate to in our equation. If it's compounded monthly, how many times per year is it compounded? Right? Because N represents compoundings per year. We know it happens monthly. Well, there's 12 months in the year. So we know N is 12. Okay? We can use that in our equation. And then we want $500,000 available for retirement in T years. So what in this equation tells us the balance of our account in T years? Well, that's what A is, right? A is the balance in the account based on the principal, the years, the rate, and the compoundings per year. So A is the balance in the account at the end of time T. So we will use A as 500,000. So there's 5 variables in this formula, right? There's A, P, R, N, and T. We know we're looking for P, and we know what the other 4 are. Keep in mind, though, you do want to be a little bit careful. R is given as 12%. So it's at an interest rate of 12%, 12% per year. And keep in mind, the formula told us we need R to be in decimal form. So we need to convert a percent, 12%, into decimal form. Well, to convert a percent into decimal form, you just move the decimal over 2 places. So that would be 0.12 is R. So we actually want this form. We don't want to use 12%. So basically, we just have to plug in these 4 numbers at this point into the formula and then can solve for P. So we'll have A, so 500,000, Actually, I'll go do this up above. So we'll have A is 500,000 equals P, which remember, P is what we're solving for. We don't know P. Then we have 1 plus R over N. Remember, R is 0.12 and N is 12. So we'll put 0.12 over 12, and then N times T. N again is 12 and T is 40. So we'll put in 12 times 40. Okay. So now basically we have this chunk here, which we can basically just plug into a calculator and see what that is. So let's do that. Let me grab my calculator here real quick. And let's actually plug this in. So we can do 1 plus 0.12 over 12. So 0.12 over 12 is what we want to start with. Order of operations tells us to do that first. So we'll do that. Gives us 0.01. Then we need to do what's in the parentheses. So add 1 plus 1. Now 1.01 is what's in the parentheses here. And that's going to be raised to the 12 times 40 power. So let's just write this down. We have 1.01 raised to the 12 times 40 power. Well, 12 times 40 is 480. So we're going to raise that to the 480th power. Doing that, 1.01 raised up to the 480th power gives us 118.6477. So this whole thing right here is 118.6477. So then we will take that. So we'll have 500,000 equals P times 118.6477. Well, now to solve for P, we can just divide both sides by 118.6477. So P will equal 500,000 over 118.67. So if we do 500,000 divided by this, or in other words, we can do 1 over that times 500,000. 4,214.16. So P equals 4,214.16. So this is what we would have to invest today if we were getting 12% interest for 40 years, compounded monthly, for it to be worth $500,000. So that would be the answer to this problem. Well, I hope you found this video helpful. If you did, please do me a favor, hit that like button down below. Huge help to my channel. And if you want to keep this brain train rolling, go check out that video right over there. I'm sure you'll find it very helpful as well. Thanks, and see you next time.